in a prior math class, probably last year, is how you can express fractions as percents. So in this lesson, we're going to take a slightly different tack than you may have before, and we're going to look at geometric strategies to help you understand how to convert fractions to percents and how to model the conversion. So I find that a lot of times students are, especially students like yourselves that are smart, they're really good at learning the procedure for doing something. Oh, the way you do this is you do these steps and the answer pops out. What I find is sometimes missing is an understanding of, well, why in the world do you do that? Okay, so we're going to try and fill that in a little bit today. So after 25 flips of a fair coin, Lorraine and her partner had recorded 14 heads. So 14 out of 25. Is this more than, less than, or equal to 15%, which is the theoretical probability? Anybody, is it?
It's more.
It's more, okay? Because 12 and a half would be half. So it's more than.
Yeah, that's about 56%, I think, if my math right.
Yeah, it's 56%. You're exactly right. So we could figure that out by going, all right, 14 out of 25 is equal to something out of 100. That's how we get percentage. What did we multiply the 25 by?
You multiply it by 4, so you multiply 14 by 4. And
Right.
4 times 4 is 16, and 4 times 10 is 40. Yeah, those together, that's 56.
Okay. Or you can do 14 and 14 is 28, and 28 and 28 is 56. You can do it that way also. So this is actually 56%. So one of the ways that we can compare different portions, which is a part of something, of the total, is percentages. So we went ahead and did this. So we did that. Sorry, I should have put that on under number 2. But let's move on. So DeMar also kept track of the number of heads he flipped. He wrote his experimental probability of flipping the heads as the fraction 7 out of 20. So this is not the same one, right? This is a different person. So he did 7 out of 20. And he wrote his experimental probability as 7 out of 20, and he wants to rewrite this as a percent. So to do that, he knows he needs to rewrite it as a portion out of 100. So he started by drawing this picture. So how many total rectangles are there, everybody? How many are there? 20. How many of them are shaded? 7. So he's showing 7 out of the 20. So after looking at his picture, he realized he could adjust this picture to show parts out of 100. Then he drew a new diagram below his original picture. So now there are 10 by 10. There's 100 of these little squares. So how many of these 100 parts are shaded? Well, that's 10, 20, 30, 1, 2, 3, 4, 5. So all he did is he took this one and divided it up to where there were 5 times as many here and 5 times as many here, right? So his new picture gives him, there are 35 shaded parts out of 100 total. which is 35%. All right, let's use a similar strategy to write 3 over 10 as a percent. So we're going to start by drawing a rectangle. And actually, let's make it, I don't know, let's make it a square. I'm cheating and using my tool over here to do those. Do the best you can. If you ever want to use a ruler for something in this class because you like things to be very neat, there will always be rulers right up there on that table. You don't even have to ask, just get up and go grab one, okay? Okay, so now I need to divide this up into 10 equal parts because it's 3 out of 10. So I'm going to go, okay. Splitting it in half is not too hard. It gets harder after that. Because now I want to divide that into sort of 5 equal pieces, and I'm just going to try and eyeball it as best I can. And I'll divide this into 5 equal parts also. And then I'm going to shade in 3 of those. So that shows 3/10, right? This is sort of like what you did with your portions web the other day, right? Where you had to show various fractions and show a picture for them. This is one of the ways you could do it. Now, I need to break this into 100 parts. Well, right now I've only got 10. And I suppose I could go up and down and do really, really, really thin ones, but what do you think might be better? Yeah, do what? Yeah, go side to side, go across. So now, how many of these little squares are shaded in now?
30.
There's 30 of them that are shaded in because it's 3 across and 10 up and down. So that's 30 out of 100 is 30%. looking around, I'm envious. Some of your diagrams are much neater than mine. All right, let's move on to page 2. So Randy was playing double heads. It's a real game. It's not something that somebody made up. It's a game in which he flipped 2 coins at the same time. He recorded the number of times he flipped 2 heads at the same time. He flipped the coin 50 times, and there were 20 times when both coins landed heads up, which he recorded as 20 out of 50. So how does 20 out of 50 compare to 50%? Is it more than, less than, or equal to 50%? It's what? Anybody? It's less than. What would it need to be 50%? Anyone? It would need to be 25 out of 50, right? That would be 50%. And here's where Randy gets into trouble. Randy claims 20 over 50 is equivalent to 70 over 100 because if I add 50 to the denominator to get 100 and add 50 to the numerator to get 70, the fraction becomes 70 over 100. Explain to Randy why 20 out of 50 and 70 out of 100, let's not get too deep into the weeds, but at a quick glance, why can it not be equivalent to one another? Yes, ma'am. Okay, 20 doesn't go into 70 evenly. We'll have some where the number on bottom doesn't go into 100 evenly either. What's another quick way you could tell? Yes, ma'am. Okay, well, you're telling him what you're not supposed to tell, and he thinks I'm supposed to add. How can I look at these and go, there's no way those two are equivalent to one another?
Because 20 times 2 is 40.
No, we're not doing any of that. Quickly, bam, I look at it and I go, you're wrong. How do I know quickly, easily, no calculations at all? Quentin thinks he has an idea.
Didn't we just establish that? Wait, never mind.
I think you were on the right track, but Warren?
Because 70 over 100 is more than 50%, and 20 over 50 is less than 50%.
Yes. Yeah, is that where you were thinking, Quentin?
I was gonna say that if you show the work on how 20 over 50 is less than 50%, you get 40 out of 100.
Okay. But I'm just looking at 20 out of 50 is less than 50%, and 70 out of 100 is more than 50%. That's how I know that this can't be right. I'm not appealing to some rule that I learned. I'm just appealing to, well, dude, common sense. 20 out of 50 is less than half, and 70 over 100 is more than half. They can't be equal. More than half and less than half can't be equal to each other. So 20 over 50 is less than, let's just even make it a half. While 70 over 100 is more than one half. So they can't be equivalent. Okay, that makes sense? So yeah, when we're talking about that, we're going to try not to appeal to rules that we have been taught. We're just going to go, well, how do I know that that rule is right? Having trouble with Oscar? It's weird the first time you use it. Turn it around the other direction. Turn the whole thing 180 degrees. So that the pencil's in your left hand and the turn is in your right hand. Keep going. Keep spinning. Keep spinning. Nope, nope, nope. Turn, turn, turn. There you go. Now go. And you don't have to hold the pencil, just hold the sharpener. Push the little black things together and it'll let go. Push the black things together and it'll snap in. Don't worry about it. It's a little weird to use at first. Okay, let's move on. So, 3 students invented a game in which they flipped coins for 1 minute and determined who flipped the highest percentage of heads. Okay, I'm a math teacher, but I'm saying you'd have to be really bored to play this game. But maybe they didn't have anything else. After the first round, each of them thinks that he or she was the winner of the game. Here's what they reported. So Maria said, I think I won. Of my flips, 12 out of 25 were heads. Autumn said, I flipped my coin 40 times and have a total of 18 heads. Since both of my numbers are larger than yours, I must have won. Kumar reported, I recorded 44% of my flips as heads. So let's change these into a percentage. So if you're doing 12 out of 25, a percentage is a portion out of what? 100. To get the 100, what should we do? You guys know the rule, yes. Yeah, multiply by 4. So we're going to multiply the 12 by 4, and that's 48. So that's 48%. And I'll write that up there by hers. Autumn said that she did this 18 heads out of 40. Now, let's talk about being smart. Being smart means you know more than one way to do something. Okay? If you only know one way to do something, you've learned, but that doesn't necessarily mean that you're smart yet. And I add the yet. So when I'm changing this, does 40 divide into 100 nicely? No. However, what if I reduce this first? What are both of these divisible by, everybody? 2. That's 9 out of 20. Does 20 divide into 100 nicely? Yes. It goes in 5 times. So that's, when I multiply, 45%. And Kumar got 44%. So they didn't ask, but who won? Maria won. What is a different way that I could have used on these rather than just dealing with the fractions. There's a different way that you can change this to a percent. Do you guys know what it is? All right, how could you change these to a decimal? Someone raise your hand and tell me about it. Someone who hasn't raised their hand multiple times today already. I think there's other people who know. I think they sit there and smile at me, and oh, Warren's like, is he looking at me? Warren, how could you change 12 over 25 into a decimal?
Multiply by 4 to make it 100.
No. Make it into a decimal. Every time you do a fraction, Quentin, you have an idea?
It's division.
Yeah, it's a division.
You do 12 divided by 25.
Yes. If you do 25 divided into 12, does 25 go into 12? No, so I'm going to add a decimal and say that goes in 0 times and add another 0. 25 into 120, it's 4 times. So that's minus 100. Subtracting, that's 20. Add on another 0,
8.
goes in 8 times. Remember that in place value, this is the hundredths place. And percent is parts out of 100, so that's 48%. Personally, if possible, I work with the fractions. I think it's faster and easier. I have some students that I've had in the past that they're like, I always divide. It doesn't matter what it is. I always make it a decimal. I'm like, okay. That's, to me, kind of short-sighted, but okay. There are some where you're not going to have any choice. There is no good way to simplify the fraction. But I'm going to give you a couple of minutes, and I want you to change each of these to percents. When you are done, check on the people around you, because I'm going to call on people, and you don't want your neighbor to be wrong. Yeah, when I say people near you, I usually mean that you don't have to get up and go see. Okay? All right. So, my calculator has magically picked the people. And if somebody misses one, am I going to be upset with them? No, I'm going to be upset with the people who sat around him who didn't check to see if they were right. Okay? Don't let your neighbor be wrong. All right, so let's see. Number 4, Alexander.
For number 1, I got 65%.
Okie dokie. So, show of hands. Who all agrees with that? All right. Shh. Number 2, desk 16, Kira. 70%? Anyone disagree with that? Oh, ho, ho. Yeah, I changed it up on you, didn't I? All right. Number 3, desk 15. Mr. Shives, tell me. 48%. Anyone disagree with that? And the last one, desk number 1, Emid Young.
I got 30%.
You got how many percent? 30%? Anyone disagree with that? Oh, we're all very agreeable. Excellent. Are there any questions about any of that? All right. So you have a lot of time. I expect you to finish your homework. Yes? No.